What is up? In today's video, we are going to be talking about calculating average atomic mass. Now, before we get into calculating average atomic mass, we need to go back and talk about isotopes really quick. Remember, we have a previous video on isotopes. If you want more information, go look for the video titled Isotopes, and we'll go more in depth here. But we essentially have elements, for instance, neon, which even though it is neon, there are three different types of neon called isotopes of neon that we will see in nature. And the reason why they are different is because they have a different number of neutrons, which results in a different mass. All along with that, in nature, we'll see different types of isotopes occur in different abundances. So if I were to have a bag of 10 neons, 9 out of 10 times I'm going to be grabbing neon 20. 1 out of 10 times I'll get neon 22, and less than 1% of the time I'm going to be getting a neon 21. So they occur in different abundances. There's more of neon 20s than there are of neon 21s. So with these, we can calculate an average atomic mass. And the average atomic mass is actually the mass that you see on the periodic table. These are the masses of the averages of all of the isotopes. And that's what's found on the periodic table. And that's why it comes down to a decimal, because it's an average of different isotopes. When we're calculating average atomic mass, we need two pieces of information. We need the percent abundance, which should hopefully be given to you on a test or on a question, and then the mass of the isotope, which will either be given to you or you will have to look at on the periodic table, but it should always be given to you. So we need those two things, percent abundance and the mass of that isotope. So in this example right here, we're given three types of neon, the same example from our previous slide, and we want to determine what the average atomic mass is of these of neon based on these three isotopes. And I have a general formula that we can follow right here, and that's the mass of A times the percent of A plus the mass of B times the percent of B. A, B are just the different isotopes that are given to us. So it can go as many, some elements have 5 isotopes, some of them have 2. So it just depends how many isotopes we have. We're going to need to consider all of them in our equation. And because we're dealing with percents here, our final answer, we don't want to be in a percent. So we need to divide that by 100 just so we can get that to a whole number or a non-percent number. All right, so I'm going to walk you through this first example using this formula that we have right here. So we have the mass of A times percent of A. Well, my mass of neon 20 is 20. So I'm just going to write 20 here. And then I'm going to multiply that by its percent, which is 90.48. A little sloppy there. Then we're going to add that to the mass of neon 21 times the percent of neon 21. 0.27. Then we're going to add that to, lastly, neon 22 multiplied by its percent abundance, which is 9.25. Okay, so those are all of our isotopes with their percent abundances. We're going to divide that all by 100. When you plug that into your calculator, it's going to be important to use a calculator here because I don't think our phones are good with the order of operations. We're going to find out that the average atomic mass is 20.02. Now, it's important. We always want to make sure that we use units when necessary. The units for average atomic mass are AMU, or atomic mass units. So you can shorten that as AMU. But this is always going to be our average atomic mass unit. That's average atomic mass unit, AMU. There we go. So we got to use that formula, this one right here, to help solve that. We find that our average atomic mass is 20.2. And if we look at the periodic table, neon's average atomic mass is 20.18. We round that to 20.2. So that's how we know we did a good job. We're always going to have the periodic table for a reference. So if it doesn't match, maybe you did something wrong. All right, let's look at another one. Practice. Chlorine has 2 isotopes, chlorine 35 and chlorine 37. In any sample of chlorine atoms, 75.77% will be chlorine 35 and 24.29% will be chlorine 37. Calculate the average atomic mass of chlorine. So we're going to follow the same steps we did in the previous one, where we took the masses, we took the percents, and then added them, and then divide by 100. So we'll do the same thing. My A, I'm just going to call chlorine 35, my A, so my mass is 35, and the percent that's given to me is 75.77. I'm going to add that to the mass of my second isotope, which is 37, multiplied by 24.29. Now this one's nice because we only have two isotopes, so we're done there. Now we just need to divide all of this by 100. Use your calculator to find that the average atomic mass of chlorine is 34.99, and then don't forget your units, AMU. And there is our answer. $34.99 AMU. Pretty easy. As long as you got a calculator and you know how to read your periodic table, boom, you're good. Here's our last example now. We're dealing with AU. This is gold. We have two isotopes. We have a mass and we have a percent abundance. So it looks like we got two types of isotopes of gold. And it looks like they both occur at the same rate. So let's see what our average comes out to be then. 197 times 50 plus 198 times 50 divided by 100. When you plug that in, that comes out to be 197.5, and then we use our units AMU. All right, so nothing really to it here. There's just some math involved, but as long as you can read the question and decipher the information that you have and what you need, no problem here. Easy work. All right, so there's how to calculate average atomic mass. There should be some more practice before this. Just make sure that you're comfortable with doing the steps, and also always remember units. All right. Keep studying your chemistry. We'll see you in the next video.